Okay, but first of all, let's go ahead and just grade. Number 2, final answer is 10 ln of absolute value of x plus c. That was a basic rule. Number 18. How? How did they go from here to here? There's a big gap of work missing.
Did they use division?
Long division, whenever there's an improper fraction. I know, I tried so hard to warn you. And Sean was trying too, because this was the one that he did a very, 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 very long one, which is one we talked about. Long division. Anytime. The top's degree is higher. Remember we wrote in our notes? Anytime you have an improper fraction, divide first. I would, in your colored pen, make a huge note of that. Highlight it. I promise you, anytime you have an improper fraction, the first step is to divide. And how do we know it's improper again? The degree of the numerator is higher. Good. The degree of the numerator is higher. So they did a polynomial long division, and they were able to rewrite as this. And guys, how do we integrate? Someone did this the long way yesterday. How do we integrate this? Do we have to choose u right now? No. We can integrate him just normal. We can integrate him just normal. We can integrate him just normal. And then, now, remember, they skip steps. I would have said right here, to be honest, I would have done minus 115 times the integral of 1 over x plus 5 dx. I would have integrated fast. Uh-oh. Slow down. Then you go ahead and say, okay, I've already integrated all of this. All I need to do is integrate this one last piece. Now do your use of. Does that make sense? Okay. And the only reason that it goes strictly to minus ln of x plus 5 times 115 plus c, the only reason it goes straight there is because the du is equal to 1 dx. Otherwise, there would be something like a divided by 2 or times 3 or something additional, so just be careful. Number 26. Let me give you a second to grade that one. As I do, let me get my spot check so that we can see, so that I can see how far you guys have gotten. Feel free, kiddos, as you're checking out your grades, trying to look at how it's going to look after or at the end of the grading period. Yes, we're going to have a test that's going to enter forever quiz that'll get put in later, but feel free to email me with any questions you have, otherwise any grades that don't look the way they should. Okay? Feel free to email me and let me know. So number 26, the final answer. They went ahead and went a little weird. Remember, they don't show U sub quite the way that we would. How did you guys, if you were doing U sub, how did you guys rewrite number 26 just real quick? And then our du just ended up being, our dx ended up being 1 du, right? But didn't you have to go ahead and get those x's in terms of u also? Right? So then I just wanted you guys to be able to check, because you see that they're doing all this crazy x stuff. What they're really doing is adding and subtracting by 1. They're doing a lot of creative math. It's a lot easier the way we go. Because then we would say, hey, we have an x, don't we have to come over and get x? X is equal to u plus 1. Look good? So we have u plus 1 times u plus 1 minus 2. Did you guys get u minus 1? Why is this so much better than that? What can we do now?
So we're already distributing.
So we have to distribute first the numerator. We get u squared minus u plus u, which cancels, and then minus 1. Why is it still so much more possible than it was at the very beginning? Hard method. We can split up. Remember, whenever we have a numerator with an addition or subtraction, we can split up, keeping a denominator. So we'd end up with u squared over u cubed minus 1 over u cubed. This would be the integral of 1 over u minus u to the negative 3 Why did I rewrite this guy as -3, but I didn't rewrite this guy? Good, good. Who is this? ln of u. Good. ln of absolute value of u. And this one I have to use my power rule. U plus 1, -2 divided by -2. Which is how we end up with the final answer once you plug in.
So, before you plug in the u,
Yeah.
you have to get rid of the x.
Before you can integrate, we have to get rid of the x's. I think the integral, we need f of u du before we can integrate.
Okay, and then the du, like, you don't put anything in for that, it's just saying it's not integrating.
Well, we actually do plug in. Remember when we come up here, we would do du equals 1 dx. We had to get rid of that guy, and the only way to legally get rid of him is when we find du equals u prime dx. Get dx alone. But in this case, it was boring. There was no, like, extra, like, half. Or
So when it equals like something else, like a numerical number,
we have to divide by that, and then substitute in its place. Does that make sense? So we don't just ever randomly write the du. We have to make sure the du is what comes out of finding the du and then solving for dx, and then we just do a substitution. But if there was something like, for instance, 2x minus 1, let's say there was a 2 right there, du would be 2. dx, I'd have to divide by 2, so then over here I would have plugged in over 2.
Oh.
Does that make sense?
and then you just, what would you replace the du? Or you, you just.
Oh, when we integrate, remember the du is like a bookend. So as long as it's there and we've legally put it in, this just says, okay, go with what's inside.
Oh.
Does that make sense? So he's not in the answer at all. You can think of him as the plus c, I suppose, but he's not in the answer at all. He's a bookend that basically just says, okay, you're legal, now go. Cool. Sorry, I misunderstood your question. Number 32, you guys can already see.
Why is it 1/5?
Ah, you forgot your u. U is equal to 5 beta, right? What would du equal?
5
And d beta would then equal du over 5. So we had to plug in for my integral. The integral of, what did we end up making? Oh, we could have just done it that way. Tangent of u times du. I can put the 1/5 in front, right? And then we can go to our forever card. Now they went ahead and did u sub using sine over cosine, but if you memorize your forever card really well, shouldn't you also be able to say that the integral of tangent is ln of, my way of remembering, ln of tangent is sine over cosine. The cosine is your u. That's my way of remembering, and since it's a cosine, I need a negative. That's my way of memorizing the rule. But long story short, we have to be memorizing our forevers. Yeah. But it's a forever card. The integral of tangent is negative ln of cosine of u. The 1/5 had to stay, and now it's time to plug in. Does that make sense, Nathan?
Yeah.
Number 56. There were a couple different ways of doing it, but one way, improper fractions, you can also check it. You can also divide if the degrees are tied. You don't have to necessarily, but you can always divide if the degrees are tied. You could have also done the u sub with x plus 1 and then plugged in like integration on crack, and it would have worked out. I'm just letting you know that you could have also done polynomial division whenever the top is greater than or equal to the degree of the top. Is greater than or equal to the degree of the bottom. They put a decimal, that's disgusting. You guys should have left it here. Or you have rewritten it. Anybody rewrite it?
No.
No?
But it's 1 minus.
You could have done 1 minus ln of 2 squared, which is 4, or you could have done 1 plus ln of 1 4. But I guess that's too far. Because remember, the negative could come up, the negative power would pop it down. But anyway, all of those are different ways of writing the same guy. We still have 106, right? Is he a multiple choice one? Ooh, 106 and 106, they give you the u sub. They went ahead and plugged in. I would say you end up with 12 over u times du over -8, which is how you end up with. I know I don't like how they show their work. I'm not saying it right there. So the answer would have been A. And number 108 was one of those long answery ones, right? But it was in the AP practice chart, which means it's kind of FRQ-ish. Kind of FRQ-ish. Let me go and zoom in on 108. It's a little bit small. And I'll give you guys just a second to check as I spot check. I think we should be able to do 150. You guys see it pretty good? Let me give you a second. Remember, tangent line, y minus y1. They had to go plug in and find it. Equals m times x minus x1. Okay, this is spot check on number 41. It's been a while since we did a spot check. 42 is 2 minutes. 41, right? Is it 31? I might be off. 31. Okay, so I'm way messed up on the board. How did I put 40? Silly. Oh, that's why. Yeah, you're totally right. We have fewer homeworks than everybody else.
Yay.
They're a bit more involved than everybody else too, though. So. Oh.
Yeah.
Alright.
Go on, minute.
You need to start a new notebook, bud.
No, I have it.
What is it?
It's a my book.
Today is the 13th, right?
Yeah.
I'm gonna buy all that this afternoon. That's how I'm going with it. That one. Like the day after, like, cause I'm not at this time, you know?
I got two checklists.
How are you doing your homework in your colored
Friday.
writing? Kill me.
Friday to
Am I not supposed to? Is
Friday.
I'll give you a 1.
So I'll even buy one for the soap and it's a great package.
Yeah.
Oh, that's not that bad.
You got further, and it was done for you. So I'll give you a 1. And people that are getting anything less than 100, remember, if you finish it, you can show it to me and get half of what you missed back.
Oh, really?
Yeah,
That's pretty good.
that's pretty good. Ooh, I think.
And niceness.
So you're
I
checking.
was not aware of this table. There's so many points I can work on that.
Oh, you didn't like him either?
Yeah.
Still trying to figure out 108.
Alright.
What did we not like about 108, guys? Was it the tangent line for you, that? Yeah, no, that's real.
Long.
I mean, she was nice, but like,
I saw her.
She was so beautiful as far as being an AP-ish question.
Trump. And I'm kidding, I haven't done this.
Oh,
So, I'm not up to par with the rest of the class.
alright. Kiddos, this problem is a great AP problem, okay? Because the very first part, read me the directions, you're supposed to write it down. Part A says, well, first of all, hold on, they gave you a function, right? Didn't they give you this guy?
Yeah.
Okay, then part A said what? Okay, what did we first learn about tangent lines?
F of x is equal to,
Did we learn this last semester sometime?
yes.
To plug in, we need a point. They said find the equation of the tangent line when or where? Pi over 6. So they gave me the, who can I plug in right away knowing pi over 6?
One.
Look, I'm only missing 2 pieces of information. Babies. Okay. How do I find y1?
Plug it in.
You put it into the original.
F of pi over 6. Hey, look at what they did right here. F of pi over 6. What do you have to know? Your unit circle. Ooh, but I hate my unit circle. Come on, I showed you the cheater chart last week, didn't I? Or was it 2 weeks ago?
Yeah.
With Luca's Brazilian song, was remember? You need tangent, right?
Wait, are you gonna tell me this one?
Oh, because it's too much.
1, 2, 3. 3 2 1 all over 2
Oh, so you just don't want
It's never okay.
and square rooted.
It's pretty sick.
Don't know why they didn't put that in. Square root of 3 over 3, 1 square root of 3. Why am I doing this?
Because it's
Sines.
answers.
Cosines, tangents, of all of the ones that you commonly get confused on. You could write this at the beginning of any test, any quiz, any AP. Why am I making a big deal about it? Some of you got freaked out when you had to plug pi over 6 into tangent. But I just say square root of 3 over 3. Hey, I got it. Let's plug it in.
30 degree angle.
1 square root of 3.
30 degrees goes with all the 3.
That's another way of thinking about it. Some of you have memorized it. That's also true. 30 degrees also goes with over a lot and up a little. So sine over cosine is going to be 1/2 over root 3 over 2. So either way you cut it, root 3 over 3 is one way of thinking about it. 1 over root 3 is another way of thinking about it.
That's what I think it is.
1/2 over root 3 over 2 is another way of thinking about it. And all of them would get you to the same tangent value. So when they went ahead and plugged in, they left it in the non-rationalized sense. You could have also done negative square root of 3 over 3 plus 1. Either way, you got to plug something into that y1 spot, which they did. Nice thing is, guys, this was a long answer. You could have stopped right there. It was a long answer. You didn't have to make it all blah. Now, hold on, wait. We're still missing this part. What goes in the slope of a tangent line spot? The derivative. So what did they do right here? Took the derivative tangent, secant squared. They went ahead and plugged in. I don't like how they wrote that. They plugged in pi over 6. Now you're like, oh, gross! Secant squared of pi over 6. Isn't that just the reciprocal of cosine squared at pi over 6?
Mm-hmm.
And what's cosine of pi over 6? Square root of 3 over 2. Oh! Flip square root of 3 over 2 and square it. Guess what? You could have put that in. It was a long answer. You didn't have to simplify it. But they did simplify it and they got negative 4/3 and pulled it out. A, tangent line. Do you remember how to do tangent lines? Okay, that should have been like a golden. I would get every single point on that every single time. Okay? AP questions. We don't just give up if it's something that we know. Oh gosh, that would be bad. Letter B. What are they asking? What's the question?
They wanted
Expression in the area.
Ah, that's like last test. Didn't they have one of those questions on the last test? Find the area bounded by? For the area, all we have to do is say, hey, we have a lower bound, we have an upper bound, plug in the function, we're taking an integral.
They didn't give us.
Oh, they didn't. They said bounded.
It bounded by x-axis, y-axis, and the function.
Okay.
Correct.
So then if it says bounded by the x-axis, y-axis, and the function, here's the struggle. You have to think about this function f of x and say, okay, if it's bounded, basically in quadrant 1, what's going on? Well, if it's bounded by, that means somehow it starts and it ends in quadrant 1. There's some sort of portion starting and ending in quadrant 1. So what they did is they said, hey, set the function equal to 0. And when does negative tangent of x plus 1 equal 0? When tangent of x equals positive 1. Hey! I want to do tangent equal positive 1. Square root 3 over 3, 1. Pi over 4. So they said, oh, it's going to happen at pi over 4. It's going to hit the 0. And then somehow, starting at 0, it comes in and then it goes out. I don't know exactly what he looks like. I think he's going to be an upside down tangent. So anyway, I know he has to come into the first quadrant at x equals 0, and he's going to go out of the first quadrant at pi over 4. So that's how they were able to figure out the bounds. And then they went ahead and just plugged in. What did part C ask for? Average value?
Yes.
Nice. An average value, all we need to do is know on a forever card where it says 1 over b minus a, the integral from a to b of f of x dx, and they just solved. Final answer could be that or that. You can't stop there, gotta plug in, but then you could just technically box it and say, I'm done. Alright, cool kids. Number 1 weight was the last one, right? Okay, any questions on odds? Any odd ones? I think I've got some of the hard ones. So we go over. Alright, 4-7. Let's practice. Our very final forever color, our very final basic rules, even though these aren't exactly basic. I'm not going to get rid of that. This is the last homework, the last section, the last everything. You guys have your forever card down from yesterday, right? I gotta get them down. Gotta have these rules.
Well, wait. I think I actually might do. Yeah,
Did you just say this is the last section?
Yeah.
and then we have a test on
Everybody said that there's a test on Friday. We're doing a worksheet tomorrow.
Like, of calculus?
Oh, no, this chapter. We have one more chapter after this.
you.
2 more chapters after this.
Okay.
He did.
But the chapters don't have like tons and tons of,
Material. Or, I mean,
We have to do those slope field things.
yeah, differential equations and slope fields are next chapter, and then areas and volumes are the last chapter.
Ooh, that sounds exciting.
yeah, we do washers.
Oh, yeah.
And then,
Yeah, rotating
and
functions and
then we
whatnot.
put on a board.
Alright, because it didn't have its down, do you have it down now?
Yeah.
So remember what you put?
Let's see, David.
Okay, we have a lot of practice to do, so let's go ahead and practice with our rules. Here, V, go. Oh, P.S. Let me pause this.
About you.
It's such a struggle because that does not look like it should go to that. Integral cosine, I know it should be trig. Integral of secant squared, I know it should be trig. Integral of tangent. ln of absolute value of cosine with a negative plus c. Okay, I know there's trig, that should be there. But if I see 1 over a square root, I don't naturally think of inverse trig. Do you guys? Yeah. So number 1, we gotta memorize these really well. And number 2, has anybody asked the question, why on earth is there an A? Do you have any A's in the derivative? Hey, so, why is there an A? Let me show you really quickly. Pencils down, you don't even have to show it. Why is there an A? Kiddos, if I was to derive sine inverse of, let's just do like x over 4, okay? If we were to derive, old school, every integral rule comes from a derivative rule, right? Okay, how would, or what would I do to take the derivative of sine inverse of u?
1 over.
You have to remember your derivative rule. It said 1 over the square root of 1 minus
Square
u squared times.
U prime.
Now, remember, can't we rewrite this to be 1/4 x?
Yeah.
You could do a quotient rule for u prime, but couldn't you also just say this 4, if I was to pull them away from the x, it'd need to be 1/4, it's in the denominator? What's the derivative of u?
1/4.
1/4. I don't need to do a crazy quotient rule, it's just 1/4. Now here's the crazy thing, would this be the final simplified, nice pretty answer?
No.
So guess what? When we take an integral of a sine inverse, it's not going to be the integral of 1 over square root of 1 minus something nasty with lots of complex fractions times, no. It's going to look nice and pretty, it's going to look nice and simplified. And how would we simplify this guy?
In that 4 and
Couldn't I make
Square root.
that x squared over 16?
minus.
Couldn't I make this 16 over 16? And couldn't I, I mean, we could bring the 4 in front, I suppose.
And then
What's 6, well, can I rewrite that to be 1 over? What's the square root of 16? And what's 4 over 4? I can make this 1 over the square root of 16 minus x squared. Square root of 16 is 4, and 4 over 4. This is the nice, pretty multiple choice answer for the derivative. So check it. If I see this in an integral with a dx, if I see this in an integral with a dx, my rule would say, hey, whenever you don't see a 1 in the beginning, or a u squared minus 1, or a 1 plus u squared, that just means there was something nasty in the inverse trig. And let me help you deal with the nasty. So instead of having to rearrange all this stuff and rewrite all this stuff, we can look at someone like this and say, whatever, you're a squared and you're u squared. So in this integral, I could say a is equal to, we'll square root that guy if it's a squared. 4. U would equal, square root that guy, and I get x. Du is just, oh, he's one of those easy dx equals du, du equals dx ones. So I could rewrite this guy to be, okay, the integral of 1 over the square root of a squared minus u squared du, which is perfect for my rule. And my rule says if I can rewrite it 1 over square root a squared minus u squared, then I can write the answer as sine inverse or arc sine, remember, same thing, of u over. This rule lets me account for something nasty in the argument that made it all nice and sweet and simplified eventually, but there was a mess to get there. So the A says, don't worry, we got you. Does that make sense? So it could be a 1 like the derivative rule, 1 minus u squared, but the problem is if there's any sort of fractioning thing, it's going to look way different in the answer. So this is what we're looking for, square root of a squared minus u squared, u times the square root of u squared minus a squared, and then 1 over a squared plus u squared, and remember, this can go either way. But pause. Remember how we started class yesterday? These two look so similar. But why were their answers so different?
Because the x didn't cancel that well nicely on the right one.
The right one, the x didn't cancel, the left one it did, meaning u sub, using u as the entire square root argument, worked perfectly on this one. Over here, that was a 1 over square root of a squared minus u squared, when u is equal to 3x. Sure.
So how can you tell?
Well, for my purposes, I usually say, start with you being who you're used to him being. But then think through in your head, hold on, if I do du, I'm going to have an x. Ooh, that one's going to be nice, it's going to cancel. This one, if I do a du, I'm going to have an x, it's not going to cancel. Wait, arc trig. So here's another way of looking at it. Whenever, ready? Whenever you have a denominator with a square root, with a squared, or with just a squared on its own, which is like arctangent. When you have a squared on its own, a denominator with a squared or with it, you have to always keep in mind this could be arc trig. And so you have to look at it and say, okay, if this was arc trig, for instance, if this was arc trig, this would be u squared, which means u would have to equal 2x. If this was arc trig, u would have to equal 2x. Du would equal 2. Would it account for that guy? And the answer is over here, if this was arc trig, u squared would be 9x squared. U would be 3x. Du is 3. I don't need an x. Oh, good, I don't have one. That's another safe way to check. Let's go get some examples under our belts. So here we go. Now let's just keep going. You can go one of two directions. You can say u is equal to the whole denominator. Let's see if it works with u sub. Or you could say, denominator is something squared. It might be inverse trig.
That's one of those.
long story short, if you guys were to make u the entire denominator, would that be very good in this one? No. Why, Sean?
Because then you have the du over 2x, and then since you have that extra x, bread just won't work out with that one on top.
You see how we're in trouble? We have this x, we'd have to come back here and say, hey, x is equal to u minus 9 square rooted. When I go to plug that in, is this any simpler than it was before? No. So this is a case where if you think ahead, if u is the entire denominator, I need an x and I have no x to cancel. So if that's true, well, stink. That probably wasn't a good idea. So if the strict u sub doesn't work, then what have you guys done? Or what did you do with the inverse trig that should help? Use the formula. And say, hey, you know what? I can deal with it if it's a squared plus u squared. So then I can go to 1 over a arctangent of u over a plus c, right? Who's a? 3. Who's u? du is equal to dx, which means dx is equal to du. So I can change this to be 1 over a squared plus u squared du, which means, what was your final answer?
1/3
Arctan or tan inverse. I'll write arctan, that's good.
x over 3 plus c.
Look at how nice that was. So, why not normal u sub, like 1 over u going to ln? Because I didn't have an appropriate du component for the variable. I need some sort of x in order to cancel out with the u prime when I do u sub, and I don't have it. So arctangent was the natural choice, and it was the only right choice. What if I was to give you... Ooh, I just did that one. That's no fun. Let's get rid of that. What if I was to give you this guy? 2 more straightforward ones. Number 2. As you guys are writing them, think about it. If I made u the entire denominator, if I made u the entire under square root part of the denominator, what would your du be?
It'd be
Negative 8x. I need an x and I don't have one. So we've got to think arc trig. Now look at your arc trig or your inverse trig rules. Which one looks like this one? Sine, good. Do you see it? Inverse sine or arc sine? Square root of, who would your a be? 1. Who would your u be? 2x. That's important. du is equal to 2 dx, which means dx is equal to du over 2. I still have to think about my u sub. We're going to go to plug in. I get the integral of 2 over square root of a squared minus u squared du over 2. Oh, hey, the 2's even cancel. That's nice. And I can go back to my rule, and my rule says, wait, my rule says if I have the integral of 1 over the square root of a squared minus u squared, how do I solve? Good, sine inverse of u, who is 2x, right, over a plus c. This is one of those where the a was 1, like the rule would normally have it. So that's no big deal. When I did the u over a, I just end up with a 2x.
Why is u 2x?
Because remember, it needs to be a squared minus u squared. So I have to ask myself, what's the square root of 4x squared in order to get my u? Or think of what squared would be 4x squared?
Oh.
2x times 2x. Does that make sense? So we're going to have to do our little square roots of u's in its inverse trig. Now number 3, let's not look at it as, oh, hey, I'm going to choose u to be under the square root. Let's look at it like this could be inverse trig. If it was inverse trig, check it. Does it seem to kind of match up with secant inverse best? Okay. It does. If it does, this 9x squared is a u squared. So kiddos, if 9x squared is u squared, who would u have to be? 3x. So think we're square rooting. Now think about it. If u is 3x, du is just 3. Am I okay with there not being an x on top?
I'm totally great with that.
Because I don't have any sort of x's in my du. So dx is equal to du over 3. Who's your a, by the way? Check out your formula. Yeah, u squared minus a squared. Square root 4 is 2. So we're square rooting each of the little pieces in that denominator.
Oh, it's you.
Now some of you are like, but what about that 3x? He's a mess. Check out your formula. It's u times the square root of. So when we go to plug in, 4 over 3x is u. 9x squared is u squared minus a squared. Guys, that is the formula, right?
Yeah.
So we get to go ahead and say, you know what? Oh, wait. See this 4/3? It doesn't cancel, right? So I'm going to go ahead and need to write the 4/3 as my constant, but that's okay. 4/3 times, okay, how do I take the integral of 1 over u square root of u squared minus a squared du?
1 over a
Good. 1 over a. Arc secant, or secant inverse, either way, of
u over a.
got it. Now go ahead and reduce the 4 into 2. So I end up with 2/3 arc secant or secant inverse, same thing, of 3x over 2. Does that make sense, kiddos?
I understand it all. My only question is why is a 2 instead of 3x? Why do you have to have
Because specifically, in order to match arc secants, I need u squared minus a squared. So the a had to come from this constant.
Okay.
And so I have to square root. And that 3x is accounted for by the u. Now, here's the problem, guys. All of those were labeled straightforward.
I'll go at it.
Let's go a little more hidden. Let's go a little more hidden. As you guys write it, I want you to think, if I made the entire denominator u, 2 to the 4th plus 16, if that whole thing was u. Careful, these ones are more hidden, they're a little bit harder. Let's get them done. If the entire denominator was u, wouldn't du be 4t cubed? If I made this whole thing u, right? And that is possible, except the problem is when I go to do du, I don't have t cubed. I only have t. That's a huge indicator when you have a division, it's probably arc trig. If you don't have enough, if I was to go to dt, and I was to solve, are all my t's going to cancel? No. So this was not meant to be an ln, a 1 over u type problem. So then we say, okay, arctangent. Tangent inverse is the only one that doesn't have a square root. If this was arctangent, who would my a be and who would my u be?
Can our
A always comes from the constant square rooted. U always comes from the variable square rooted. Why is there a t up top? Because check it.
Yes, baby.
I need a t up top. My u was a t squared, so he's going to have a du with a t. So my dt is going to equal du over 2t. I'm not afraid of that t. I needed it. So Sean, another hint, when your u sub of the entire denominator doesn't get enough, it's still probably inverse trig. Because even when you have a variable on top, check it. If your u is something like t squared, well, that t is fine. Because when I go to plug in, I'll get u squared plus a squared times du over 2t. Got it. Take out a 1/2. And now use your rule. Isn't this going to be 1 over a times arctan or tangent inverse of u over a? Using my rule. So I'll end up with 1/8 tangent inverse of t squared over 4. And then guys, remember, when that over 4 is inside the inverse tangent, I can't just randomly pull him out. He's stuck, I leave him in there. The 1/8 is outside, the 1/4 is inside, they're stuck. Ooh, sorry, number 5. It's a little too zoomed out.
One more.
I'm not going to do the whole thing for number 5, but can you guys tell that this is also inverse tangent?
Yeah.
A would equal, One.
Is just
U would be,
X minus
X
2.
minus 2.
yeah. So you can have other things being squared. Du is equal to dx.
That's nice.
Pretty quickly we would get 1 over problem. How many times would you naturally, in simplifying, leave the denominator looking like that?
Never.
Never. You would have the denominator looking like this. Struggle.
We have the square.
If I make you the denominator, it's not going to work. This is an inverse tangent, but how on earth am I going to figure out A and U if I don't see anything squared?
Factor.
We got it.
Jeez.
That.
We got to complete that square.
Game show.
And say, half of 6 is 3. 3 squared is 9. That's the only thing that'll get me x minus 3 squared. But what I do inside, I gotta counter it on the outside. But now all of a sudden, I'm ready for, oh, A is 2 and U is x minus 3. But what did I have to use to get there?
Completing the squares.
That's an Algebra 1 topic. If you don't remember complete the square, can you review it?
I do remember.
Yeah, you can. Alright, kiddos, this homework is due tomorrow. Get as far as you can. I showed you the tricky one.
Okay, I'm almost done with the.
Michael gets with 4.6.
Yeah.
Because, this one's one here. This one, for this, but for inverse secant, you need 1 over n. So I wrote 1 over 2. Yeah, I forget what it was. Here. And then I reduced, so I got 2 things. Does that make sense? Good, good, good. $5.